Hi, good morning everyone. Welcome to Hackatronics. Today we are starting our first tutorial for the course Smart System using AVR. In this tutorial, you will get an introduction of microprocessors and microcontrollers and their types. First, we will start with microprocessor. Microprocessor or simply processor is an IC that has only the processing ability. They do not have any RAM or ROM inside them. You have processors in your laptops, mobiles, etc. like Intel Pentium, Intel Dual Core, or the latest one i3, i5 or i7, etc. A microprocessor requires RAM, ROM, IO ports, etc. to be connected externally to them in order to make a system. This is just like a computer system where you have processor, RAM, hard disk, input-output devices connected together. On the other hand, a microcontroller is just like a single chip computer. It contains processor, some memory, various peripherals like analog to digital converters, timers, etc. inside them. They are designed for some specific purposes. That's why they have small computing powers in megahertz range as opposed to your i3 or i5 processor which process data in gigahertz range. There are large number of companies that manufacture microcontroller. To name a few, we have Intel, Atmel, Texas Instruments, Freescale, Philips, etc. Here is a block diagram of microcontroller. As you can see, it contains ROM, RAM, timers, serial peripherals, etc. Do not put any stress on the values at this stage as they vary from one microcontroller to another microcontroller. Till now, you might be able to differentiate between microprocessor and microcontroller. But this picture will clear it out. Look, in the first figure, a microprocessor is externally connected with RAM, ROM, timers, IO ports, etc. While in the second figure, you will see a microcontroller contains all the peripherals inside itself. The next we will study is the type of processors or controllers. They are classified on two bases. First, according to instruction set. Second, according to memory architecture. According to instruction set, they are classified into RISC and CISC. And according to memory architecture, they are classified into von Neumann architecture or Princeton architecture and Harvard architecture. I will take a help of an example to explain RISC and CISC. Consider a case where you have to write a program to find A cross B, where A equals to 5 and B equals to 4. Now, go back into your childhood memories. How did you perform a multiplication of 5 and 4? If I guess, you would have added 5 4 times, that is 5 plus 5 equals to 10, then 10 plus 5 equals to 15, and then 15 plus 5 equals to 20, and 20 is the answer. The same has been done here, as you can see. Using this method of calculation, the calculation in each step is easy, but the number of steps are larger. Such type of processors or controllers are known as RISC, that is reduced instruction set computers. Now here you got a new term, instruction set. What is this? In basic terms, we can call instruction set as a list of formulas that are valid. Now if we convert this method of multiplication into a program, then you can see we will repeat step 1 and step 2 3 times. This is clear as you can see in the picture. Now we will study what is CISC. Again, same example of multiplication. Now come back from your childhood memories, you have grown up now. If anyone asks you what is 5 into 4, you will calculate for some time. I know 5 into 4 is easy, but just think it as an example. After some time, you will say it is 20. Yes. In this method of calculation, you just went through one step, but it was a complex one. Remember, multiplication is a complex operation in comparison to addition. Such type of processors or controllers are known as complex instruction set computers. I hope the difference might be clear to you. RISC, that is reduced instruction set computers, it reduces the operation time by shortening the clock cycle per instruction or step, means they take less time per step, while CISC, that is complex instruction set computers, allows user to apply one instructions as an alternative to many in simple instruction. That is, they use complex steps so the whole program is short but the operation time is higher. Remember, earlier I told you that on the basis of memory architecture, processors or controllers are classified into two, that is Harvard architecture and von Neumann architecture. First we will study about Harvard architecture. Since Harvard architecture was developed by Harvard University, that's why it is known as Harvard architecture. You can see few new terms in the diagram. The first is memory. It is program memory and data memory. Program memory is the memory where the program or the code is stored. Data memory is the memory where data like values of various variables, constants, etc. are stored. Another thing is bus, as you can see in the diagram. What is a bus? Here, the bus refers to a group of wires that is used to connect two devices. Buses are of two types, data bus and address bus. Data bus is the bus that carries the data between the processor and the memory. Data is again values of various variables, constants, etc. I hope you know that a memory is divided into small blocks or segments known as memory locations. Each memory location has a specific address. So, the address bus is used to read the address of a particular memory location. In Harvard architecture, program memory and data memory are separated, as you can see in the figure. And there are separate buses for data and address. Now, second we will study is von Neumann architecture. It is also known as Princeton architecture because it was discovered or developed in Princeton University. In von Neumann architecture, program memory and data memory are shared, that is, they are common. And address bus and data bus are also shared. Now, one important thing I would like to tell you that in this generation, you would not find anything that is completely von Neumann architecture based or completely Harvard architecture based. Today you will find modified Harvard architecture or modified von Neumann architecture. Now what is this modified architecture? In modified Harvard architecture, you will see Harvard architecture with some features of von Neumann architecture. Similarly, in von Neumann architecture, you will see von Neumann architecture with some features of Harvard architecture. Similarly, you will find enhanced RISC or enhanced CISC. Enhanced RISC means RISC with some features of CISC, and enhanced CISC means CISC with some features of RISC. So that's all in this tutorial. Stay tuned for the next one and do subscribe us on YouTube.